Hey guys, welcome back to another fun-filled day of science. It's me, Mr. Lewis, here with you again for the 8.2 section, chapter 8, section 2 video, the behavior of gases. And I'm not talking about those other ones. All right, bell ringer, your bell ringer is on the board there. Go ahead and take a look at that. Go ahead and pause it up, read it, and then go ahead. You know what to do. Hit your answers up on edmodo.com. Here we go. All right. Dun, dun, dun. We have two objectives today. First off, we're going to describe three factors that affect how gases behave. And then we're going to predict how a change in pressure or temperature will affect the volume of gas. And so we'll talk about those two different things as well when we get to that point. That's at the end of the video. So this hopefully will be kind of a short video, but we'll talk about it and see what's going on. Now, when we talk about temperature, if you look outside today, it's a beautiful day. It's 85 degrees outside right now when I'm looking at recording this video. When we talk about temperature and we talk about heat and cold, what we're actually talking about is the particles of the air, how fast they are moving. Now, if we're talking about hot days, if we're talking about hot temperature, what's happening is those particles are moving faster and faster. And since those particles are moving faster and faster, the air around us feels warmer. It's the same thing for you. If you were just standing still, you wouldn't feel that warm. But it doesn't matter how hot it is outside, yes, you'll feel a little bit warm. But if you start to run and run around in circles and run, you're going to get a lot hotter. That's because you're moving faster. But if you were to stop, settle down, cool off, you would end up feeling cooler, and that's because you're not moving. The same thing with air particles and temperature. When those air particles are moving very, very, very fast, it's very warm. When those air particles are moving very slow, then it's cooler temperature, okay? So that's one thing for us to keep in mind. On a hot day, we talk about balloons, hot air balloons. On a hot day, you don't need as much air or as much gas to fill a balloon. All right. Now, you may think, well, that's not right, Mr. Lewis. Well, it is right. And the reason for that is because those air particles are moving a whole lot faster, so there's more space between them. Okay. Since there's more space between them, there is less of that gas or that air needed to fill up that balloon. Whereas on a cool day, you have to put more gas or more air into that balloon to get that balloon to get to the same size. All right. So when we talk about temperature, temperature has an effect on our gases. That's one thing that affects the gases. Next is volume. And of course, we already know what volume is. Volume is the amount of space an object takes up. All right. Because the gas particles are spread out, the volume of gas depends on the container that gas is in. So for any gas, it doesn't matter what type of gas it is, the volume of that gas depends on the container that gas is in. And it's only because there's the gas particles, there's so much space between those. Now, there could be a lot more, there could be a lot less, but because of how spread out those gas particles are, that tells us, that means that we need, that the volume depends on the container that the gas particles are in. All right. Interestingly, when we talk about gases can be compressed or they can be squeezed together. All right. And it's simply because of the way that the particles move and the way that they operate and the way that they interact with each other. So, for example, if you wanted to make a balloon dog or something, the reason you're able to do that with a balloon filled with gas or with air, whether you blow it in or some other type of gas, the reason you're able to do that is because gas particles can be compressed, they can be squeezed together into a smaller volume, and it's not going to really affect, unless you put way too much in there, it's not going to really affect the balloon or the container that it's in. However, if you were to try to make a balloon dog out of a balloon filled with water, the liquid particles cannot be compressed as easily as the gas particles. So when you do that, you will probably pop your balloons and get all wet, and that wouldn't be cool. All right. Also, when we talk about pressure, so this is the third thing. First off, you had temperature, then you had volume, and now you have pressure. That is the three factors that affect gas. All right. Lastly is pressure. Now, when we talk about pressure, all that simply means is all the particles inside of gas are hitting the inside of the surface of whatever container they're in. Okay. So the more of those particles hitting the inside of the surface with a greater force, that is pressure. All right. So you can see right here it says the amount of force exerted on a given area of surface is called pressure. So the more force those gas particles are hitting the inside of that container that they're in, the more force they're hitting that with, the more pressure that container has. In your book, it talks about a balloon and it talks about a beach ball and talks about a basketball. It says when more particles hit the inside surface of that basketball, the force on the inside the surface of the basketball increases. That also increases the pressure. So there's more of those particles and they're hitting harder and harder and harder on the edge of that basketball or the inside of that basketball. That means there's greater pressure in there, as opposed to the beach ball. Now the beach ball may be the same size as the basketball, but the beach ball there's less force hitting the inside, less pressure hitting the inside surface of that beach ball. Okay, now, how do we know this stuff happens, and what are we going to talk about as far as gas laws? Okay, remember that a law is something that's been as a theory that's been proved over and over and over and over again, and since it goes over and over and over again, we know that this is what's going to happen. Now, there's two types of laws. There's two laws that tell us how gases behave. One is called Boyle's Law. The other is called Charles' Law. Now, we're going to talk about Boyle's Law first, and then we'll talk about Charles' Law. And then I'm going to show you a slide that sort of represents what we're talking about as far as Boyle's Law and Charles' Law is concerned. Now, Boyle's Law was created by a guy by the name of Robert Boyle in the 1700s. And he was doing some experiments with gas, and he discovered some things. He discovered that for the fixed amount of gas at a constant temperature, okay, in other words, they have this exact amount of gas at this exact temperature, the volume of the gas is inversely related to the pressure. Now, what does that mean? That means that if you have this amount of gas and it's kept at this temperature, the volume of that gas is going to go up if the pressure of the gas goes down. Or the volume of the gas is going to go down if the pressure of that gas goes up. All right. So I put this in easy words for you to understand. At a constant temperature, if you increase the volume of the gas, the pressure will drop, or if you decrease the volume of the gas, the pressure will rise. So it's inversely related. Inversely opposite means oppositely related. So it'll end up if you kept the exact same amount of gas, and you kept that gas at a certain temperature, then the volume of the gas will go up if the pressure of the gas goes down, or the volume of the gas will go down if the pressure of the gas goes up. Okay, that's Boyle's Law. Now we have Charles's Law. All right, Charles' Law states that for a fixed amount of gas at a constant pressure, the volume of the gas changes in the same way that the temperature of the gas changes. Okay, so what that is saying is, if we have a constant pressure on that gas, in other words, we kept that gas at a certain pressure, we didn't change that gas, and it also has to have the same amount of gas as well. So we keep the exact same pressure on that gas. When we increase the volume of that gas, well, guess what? The temperature of that gas will come up as well. When we decrease the volume of that gas, temperature of that gas will decrease as well. So when we talk about Boyle's Law and Charles' Law, Boyle's Law talks about constant temperature. Charles' Law talks about constant pressure. All right. So at constant temperature, our pressure and our volume is inversely related, and at a constant pressure, volume and temperature are going to be directly related. They're going to both go up or both go down at the exact same amount of time. So what does that mean? Well, here you go. If you look over here, this is the first one here. This is a lifting piston. This is an experiment that you can do to discover Charles' Law and Boyle's Law. Okay, it says right here, it says lifting the pistons, let the particles of gas spread far apart. The volume of the gas increases as the pressure decreases. Why? Because there's not very much pressure between this plate here and all the gases inside here, the gas particles inside here, so they can move around all willy-nilly if they want to. But if you release that piston, it allows the particles of gas to return to their original volume and pressure, and then you push down on the piston, it forces the gas particles close together. The volume of the gas decreases as the pressure increases. So the amount of gas, the amount of space between the gas particles is decreasing, all right, as the pressure is increasing. So you guys can kind of see here, there's a lot of space between the particles here, and over here there's not a lot of space. That's because there's more pressure going on there. We look over here at Charles' law. So if we decrease the temperature of the gas, causes the particles to move more slowly. The gas particles hit the piston less often with less force, so the volume of the gas also decreases. And then you increase the temperature of the gas, cause the particles to move more quickly, and the gas particles hit the piston more often with greater force. The volume of the gas increases. So this right here, these are good pictures right here, good explanations for you to understand Charles' law and Boyle's law. Okay, remember Boyle's law deals with constant temperature, and Charles' law deals with constant pressure. All right. Any questions you guys will be able to ask me in class and stuff. Because it is review time. It's time for the review. All right, here's your review right here. I'll be quiet for a little bit so you guys can go ahead and take your notes. Remember that you'll be doing your own notes starting from Chapter 9 on. I will not have this section review slide down here starting from Chapter 9 and on. Okay, well, you guys, I hope you guys enjoyed that. We've got one more video to do for Chapter 8, and we'll be done in Chapter 8. And moving right along, guys. You guys have a great day, and I'll be seeing you in the future.